Hi, welcome to 3.2 about radical expressions. We're going to start on page 10 of your notes packet. This up at the top, I did not write that, and we're not going to go over that. So we're just going to start right here with square roots that you hopefully already know. So square root, remember a square root is, we're looking for what times itself gives you whatever is in that radical sign. So since 7 times 7 equals 49, the square root of 49 is 7. Square root of 100 is 10. And then the cube root means whatever times itself 3 times gives you the number in the radical. So since 3 times 3 times 3 is 27, the cubed root of 27 is 3. Okay, so now we're going to take a look at these right here. So we're talking about a way for us to write these radicals or these square roots or cubed roots in terms of exponents. And 1/2, the exponent of 1/2 is actually the same thing as the square root of 49. So if you were to put this in the calculator, if you wanted to put that in the calculator, you would do 49 and then you would do that little caret symbol, and then you would do 1/2 or 1 divided by 2, and you would still get 7. This one would still be 10, and this one would still be 3. So these and these are equal, and this is equal. So let's take a look at how we could see these things in exponent form and put them in radical form. So the numerator of your radical is going to be the exponent, or the numerator of your exponent is going to stay the exponent, and then the denominator is going to be the root. So for example, on this one, w is going to go inside. It's going to be w squared, and then since there's a 3 on the bottom, that's going to be the cubed root. So this one would be the 4th root of 5. This one would be 6 to the 3rd, the 5th root of that. And then this one, since it's 1 over x to the negative 2/3, remember negative means it's unhappy, and so it's going to go to the other spot. So it's going to go up here, and that'll be x to the positive 2/3 over 1, which is still the same thing as just x to the positive 2/3. So that's going to be x squared, because that's our numerator, and the cubed root, because that's our denominator. So that's our final answer on that one. Okay, well, let's take a look at the other side. So in this one, we're going to take a look at using a powers table to help us do some things without a calculator. And it can be easier at times when we're working on simplifying some things, because with a calculator, we'd have to guess and check a little bit more, whereas this, we can kind of look and see if we have some familiar numbers to help us out. So let's take a look at this. So the first one here, we have 25 to the 3/2. Now, we can write 25 as, and hopefully you already know this one, 25 is the same thing as 5 squared. So we can rewrite that as 5 squared, and then that's the same thing as 5 squared over 3/2. Now, remember the power rule, power of a power is that we multiply these together. So the nice thing about having that, 2 is the same thing as 2 over 1. And if I multiply 2 times 3, I get 6. 1 times 2, I get 2. So that's the same thing as 6 over 2 or 3. Or you can think about cross-canceling the 2's, and either way you're going to get 5 to the 3rd power. And then since we want to evaluate, we actually want the number for that one. So we're going to look at 5 to the 3rd power, and that's 125. Okay, let's do 2 more. We're going to do this one And then I think we'll do this one here, and then you can try some. So in this one, we're going to do that negative means it's going to go to the bottom of our fraction, and it's still going to be to the 1/2 power. That's the same thing as 1 over the square root of 49, and the square root of 49 is 7. So our answer for that one is 1 over 7. Okay, we're going to take a look at this one. I happen to know that 32 is 2 to the 5th power, but if you don't, you could always come up here and kind of scan for 32, and when you find it, just see if there's something useful about it. This one is 2 to the 5th power, and since we have the 5th as our denominator here, that means it's going to cancel that radical out and be helpful for us. So I'm going to rewrite 32 as 2 to the 5th power, and I'm going to multiply that by 6/5, and so the 5's cancel out, and I have 2 to the 6th power, which I know, but if I didn't, I could certainly look up here and see that 2 to the 6th power is 64. So my answer for this one is 64. Okay, see if you can use that powers table to kind of help you manipulate some of these and turn them into easy problems. All of them should have something in the power table to kind of help you. So pause it, give those a try, and then come back. Whoops, hang on. There we go. Okay, so there are all your answers. You can take a look at those. And any of them that you're having trouble figuring out what I did on them, go ahead and put a star by them. And of course, we will practice this in class next time too.